Pydantic AI's tool execution mechanism is wrapped here by subclassing WrapperToolset, enabling a logging toolset to intercept every tool call before delegating to the underlying prepared toolset and capturing results on the way out. The code you are about to see constructs a logging toolset that records each call's name and arguments, applies an increasing sleep delay to stabilize ordering, forwards execution via supercall tool, and logs both success results and exceptions.
Import Asyncio. From typing extensions, import any. From Pydantic AI import agent, run context, toolset tool, WrapperToolset. From Pydantic AI models, test import test model. From prepared toolset, import prepared toolset. Log equals class logging toolset WrapperToolset. Async def call tool self name, SDR tool args, dict SDR any CTX, run context tool, toolset tool any. Log append calling tool name R with args, tool args R. Try. Await Asyncio, sleep 0, 1 len log hash 1. Result equals await super, call tool name, tool args CTX tool. Log append finished calling tool name R with result, result R. Accept exception as E. Log append error calling tool name R, E. Raise E. LC. Return result. Logging toolset equals logging toolset prepared toolset. Agent equals agent test model. Toolsets equals logging toolset, hash 2. Result equals agent. Run sync call all the tools. Print log. Calling tool temperature Celsius with args. City. Calling tool temperature Fahrenheit with args. City. Calling tool weather conditions with args. City. Calling tool current time with args. Finished calling tool temperature Celsius with result 21. Finished calling tool temperature Fahrenheit with result 69.8. Finished calling tool weather conditions with result it's raining. Finished calling tool current time with result data time data time.
This code demonstrates the WrapperToolset pattern for intercepting tool execution. Logging toolset subclasses WrapperToolset and overrides call tool to log entry and exit of each tool call, wrapping the underlying prepared toolset. The agent is constructed with this logging toolset, and when run sync is invoked with a prompt that triggers all tools, the wrapper intercepts each call, logs arguments and results, and delegates to supercall tool. The try except else structure ensures errors are logged before re-raising, and the artificial Asyncio sleep scales with call count to guarantee deterministic log ordering since tool execution is concurrent. This approach lets you add cross-cutting concerns like observability or retry logic without modifying the wrapped toolset, trading a bit of latency for non-intrusive instrumentation. Let's break it down.
Import Asyncio. From typing extensions, import any.
Imports Asyncio for asynchronous execution, and any from typing extensions for type-agnostic type hints.
Log equals
initializes an empty list assigned to the identifier log, available for later appending log entries.
Class logging toolset WrapperToolset. Async def call tool self name, SDR tool args, dict SDR any CTX, run context tool, toolset tool any. Log append calling tool name R with args, tool args R. Try.
Extends WrapperToolset to override call tool, logging the tool name and arguments to log before attempting execution.
Logging toolset equals logging toolset prepared toolset. Agent equals agent test model. Toolsets equals logging toolset, hash 2.
Creates a logging toolset instance from prepared toolset, then constructs an agent with test model as its model and the logging toolset attached via the toolset's parameter. The WrapperToolset pattern gives you a clean interception point around every tool call. Logging toolset subclasses it, overrides call tool, and wraps the underlying prepared toolset without touching its logic. Before delegating via supercall tool, it logs the name and arguments to log. After execution, it logs the result or catches and logs exceptions before re-raising. The try except else structure is what makes that logging safe. Errors get recorded, but don't swallow the failure. The sleep delay scales with the call count to keep log ordering deterministic, since tools run concurrently. All of this wires together through the agent constructor, where the logging toolset is passed in via toolsets, so every tool the agent calls gets intercepted. The trade-off is straightforward. You accept a bit of latency for non-intrusive observability that never modifies the wrapped toolset itself.
The wrapper counts each call, and every tool waits through growing logs after each sleep.